Good afternoon and welcome to WinHEC 2006. My name is Richard Russell. I'm a development manager on the Windows Client Performance team, and I'm going to talk to you today about Windows Vista system requirements and using WinSAT to help you build PCs optimized for Vista. We're going to talk a little bit today about the system requirements, specifically about the requirements for the new Arrow user interface, an overview of WinSAT and some of the scenarios that it's used in, and some of the technical details behind the assessment tool. Here it is, the Windows Vista system requirements. Pretty straightforward stuff. I think a lot of you have probably seen this in the press or up on the website, on the Get Ready website, since we launched this last Thursday. Very straightforward. Windows Vista requires for minimum supported, we require 800 megahertz CPU and really recommend a 1 gigahertz or better processor. The minimum supported, the minimum for Vista is 512 with a minimum recommended of a gigabyte. For graphics in the minimum supported area, we really require pretty basic graphics. Anything that will work with XP will work fine with Vista. And that's pretty much the same thing for Home Basic for minimum recommended, with the exception that we really want DX9 capable graphics there for Home Basic. And then of course for the other SKUs for minimum recommended, we really recommend Arrow capable graphics, and I'll talk a lot more about that shortly. From a graphics memory perspective, really the minimum supported is, again, very much like XP. Pretty much anything that works with XP will work fine with Vista from a minimum supported perspective. For Home Basic, 32 megabytes is really the minimum that you want to run Vista in. Even the Home Basic product is more graphically intensive than XP and will really use a little bit more graphics memory. But since Home Basic really isn't focused on desktop composition or the Arrow user interface, it can get by fine with a smaller amount of memory. However, the minimum recommended graphics memory requirements for the premium SKUs are at least 128 megabytes. And I'll talk a little bit more in detail when that's a little bit less and when that's a little bit more. The hard drive sizes are really pretty low here, and they're really just reflective of what it takes to get the operating system installed and up and running and have enough free space for some other small things. Of course, other features in Vista are going to require more hard drive space. The Windows Vista generally comes on a DVD-ROM, and the retail packages are pre-installed on OEM systems, so the premium SKUs all really require DVD. But for minimum supported and for Home Basic, a CD-ROM is fine, and users that upgrade can order the media on CD-ROM, and there'll be a certificate in the box for that, and it's very low cost, really just to cover the cost of shipping that media out to the user. And of course, for the premium SKUs, we also highly recommend internet access and audio output capability. Vista will use the same type of audio subsystems that XP leverages today, for example, AC97 and sound cards, but it will really take advantage of the new UAA audio architecture that you'll find on new PCs. A few interesting footnotes is that we really don't distinguish from a graphics memory perspective between local and dedicated memory. In other words, dedicated memory on a graphics card or UMA memory used by many of the integrated graphics controllers or some of the new hybrid graphics cards from the IHVs today. If you look at the logo requirements carefully, though, what you will see is that while it is possible to build a logo compliant system with 512 megabytes, if a system has integrated graphics, we really require 1 gigabyte. And that's because the graphics subsystem is sharing memory with the CPU. And so you don't get the advantage of the discrete graphics memory like you do on a card. So Vista will really need a gigabyte of memory with integrated graphics for their premium SKUs. The processor speeds that we specify, the 800 megahertz and the gigahertz, are the nominal or the maximum processor speeds. We're not disallowing processors that lower the clock rate for power management technologies. Those are the nominal speeds. Oh, and the CD-ROM or DVD-ROM doesn't have to be built into the system. It just has to be accessible via USB or FireWire or some other interface like you see on mobile systems. As you may have figured out, one of the most important hardware resources for Windows Vista is RAM, memory. Windows Vista has a minimum supported requirement of 512 megabytes of system memory. This is not a sandbag requirement. There's been a lot of comments over the many years that sometimes we come out with minimum recommended or minimum supported requirements that are really unrealistically low. That's not the case here. 512 megabytes is a realistic memory configuration for Windows Vista. It will get very credible performance in everyday computing scenarios in 512. It is not an unrealistically low value. Out of the 512 megabytes, though, we only allow 64 megabytes of memory to be allocated for other usage, such as a graphics buffer. And when I mean allocated for other uses, that means not available to the operating system. So if you went and called the appropriate Windows APIs, that the system memory might be reported as 448 megabytes. It can't go any lower than that. Out of 1 gigabyte, though, up to 256 megabytes of that can be used for UMA graphics memory or for other purposes. When running Aero, and for system shipping and meeting the premium logo requirements, 512 megabytes must be available to the operating system. This is why systems with integrated graphics that meet the logo requirements have to have a gigabyte of memory. That's where that requirement is derived from. There are some feature-specific requirements in Vista, and I'm not going to talk about all of them here because they're all listed in very detailed ways in other places. But for example, TV recording, clearly not going to do TV recording in a minimum supported or minimum recommended requirements. Gee, because there's no tuner. There's a lot of requirements like this in Vista. Things, for example, like tuners, like digitizers, or other peripherals necessary for supporting certain features in Vista. This is not true for just peripherals that may be plugged in or go on the PC interface. It's also true for capabilities that may be in the graphics controller. For example, we have some of the higher-end PIX features, for example, require Pixel and Vertex Shader 2.0 implemented in hardware. So you won't get some of the more advanced features if you don't have some of those features in the graphics controller. HD DVD playback is another feature that requires capabilities above and beyond the minimum supported or minimum recommended. For example, how many of you are familiar with the performance requirements of HDVD? Not very many. It's a very demanding format, and it really requires hardware acceleration in the GPU, or really today's modern dual-core microprocessor to support that very, very well. Who's here is interested in the requirements for Aero? Yeah, lots of hands. This is something that there's been a lot of confusion about over the last several months and a lot of questions about, and I hope today that I can answer a lot of those, and there's plenty of time will be plenty of time at the end of the presentation for you to ask me questions about that. So Windows Aero, it means a lot of things. Visual quality and reliability. There's productivity enhancements that go along with Aero, and the nice new style of the Aero user interface. So Aero really means several things. It means desktop composition. It means the Flip 3D feature and the Alt-Tab feature. For many degrees, it also means stability and reliability, as the system is much less dependent upon the behavior of applications to keep the desktop looking correct. In other words, how many of you are familiar with some of the painting artifacts that you see in XP today when the system is under performance stress? In other words, when you drag a window across the screen and there's lots of painting problems or windows don't paint in the background, who has not seen those type of performance problems on XP? Nobody. You'll see those a lot less on Vista. And the big reason is the fundamental technology that underlies Aero called desktop composition. It's essentially a retained graphics model where the operating system becomes responsible for managing what's on the screen, not the applications themselves. As you can imagine, the performance requirements, both from just a raw performance and from a memory capacity perspective, are much higher for a retained graphics model like that in Vista than it is for the older style update model that you see with GDI. So logo requirements are very detailed in this regard because the goal there is that we want to ensure a good user experience with Aero. And the performance bar is considerably higher than that for GDI style graphics in XP. You'd be amazed at how many questions I still get about this. And when people are running Beta 2 or even internally to Microsoft, I'll get an email that says, Richard, I can't run Glass. What's wrong? What's wrong with my system? And still about 30 to 40% of the time, they don't have a WDM driver. For those of you that aren't aware, the Vista supports a new graphics driver model called the WDDM. This is very different from the long-standing driver model in XP that we now call XPDM. Desktop composition and all the features that are built on top of it only work with WDM drivers. Systems that either don't have one because it's not installed, or there's not one available for the graphics subsystem on the part, will not be able to run Aero or anything derived from desktop composition. Some of the other requirements for Aero are a DX9 class GPU that supports Pixel Shader 2.0 in hardware. It's not sufficient to support Pixel Shader 2 merely in the driver. It's not nearly performant enough to run the shaders that handle a lot of the effects. The graphics must be able to support and run at 32 bits per pixel color depth at the resolution of the card. This is another one of the things that drives the memory requirements for Aero. So a lot of older graphic subsystems, even if they had a WDM driver, wouldn't be able to support Aero on modern large panels specifically due to this reason. And then the requisite amount of graphics memory and the requisite amount of graphics performance. So another area of confusion about Aero is how much graphics memory does it take? There's been a lot said in blogs and on the web that, oh, it's 64 megabytes. Well, and the actual answer is it depends. And what it really depends primarily on is the size and number of monitors that the user has connected to the system. Larger monitors and more monitors require correspondingly more graphics memory. What we've tried to do in the logo requirements is make this as simple as we can, but there are 3 basic levels of that. We allow 64 megabytes for resolutions up to but not including 1280 by 1024. And the reason the reason we worded this requirement this way is to take the widescreen smaller notebooks into account. If you guys are familiar with some of the very early logo requirements, it was 64 megabytes at 1024 by 768, and we modified that to the current requirements to allow those smaller wide form factor screens to run with 64 megabytes of graphics memory. Panels up to and including 19.2 by 1200 require 128 megabytes, and panels larger than that really require 256. For desktop dual monitor scenarios, you essentially double everything, where you want 128 megabytes at dual 1280 by 1024 and 256 megabytes for larger dual panel configurations. The interesting thing is that if you read the logo requirements carefully, you'll see that we exempt mobile platforms from the dual monitor requirements. That's why we say for desktop dual monitor configurations. The reason is all mobile systems that we've seen, and we talked to everybody about this, they're all dual monitor capable, but they're not dual monitor capable, or the scenarios that they're designed to support aren't the same type of scenarios that desktop dual monitors are designed to support, which is full up 24/7 dual monitor capability on desktops. On mobile systems, that second monitor tends to come and go, be used for lighter weight tasks such as PowerPoint presentations or in mirror mode, which is quite a bit different set of scenarios than on desktop. So we relaxed that requirement quite a bit for mobile. It didn't start out that way, actually. So Aero also requires quite a bit of graphics memory performance. When we first started working on the Aero user interface and desktop composition in general, the assumption was that the primary performance characteristics of the graphics subsystem that we need to drive this new user interface would be shader performance. Well, after a lot of work and after the DWM team did quite an excellent job of getting the DWM quite performant, we learned that the primary bottleneck or the primary determiner of how good the user experience is with desktop composition is actually video memory bandwidth. And it's very straightforward. It's nothing too difficult. It's the ability for the graphics card to copy and deal with large textures. The textures that represent windows that are visible to the user are, plain and simple, they're just big. And there's one of them for every window, and there's another one for the desktop. And if you have 2 monitors, then there's 2 big ones for the desktop. And that's one of the things that drives both the memory requirements and the performance requirements. You need lots of memory to hold large numbers of textures that represent windows, and you need lots of video memory bandwidth so they can be copied and manipulated in video memory and composited onto the desktop. And if you think about it, the default composition rate, or how often Vista paints the desktop under Aero, is the native frame rate of the monitor. Typically, nominally that's 60 hertz, but it could be as high as 75 or 80, depending if people have turned their monitor up. So you can see how 2 large panels or monitors running at a high refresh rate require with lots of windows up on the monitors require a lot of memory to drive that or to support that configuration, and a lot of video memory bandwidth to support that type of composition rate. In the logo requirements, you'll see a very important value, and that's 1,600 megabytes a second as measured by the logo test tool. We'll talk about that here in a minute. So the Aero AT tool, the logo test for the System Fundamentals 046 requirement in the system requirements document, tests both the performance of the graphics subsystem and how much memory it has to make sure they meet the logo requirements. It uses a tool that's built into the operating system called the Windows System Assessment Tool, WinSAT, that we talked about a year ago. Actually, a year ago today. It doesn't seem like a year. The tool itself is targeted at OEMs, IT pros, and enthusiasts, and it's delivered in the WDK. So it's part of the normal set of logo tests that you'll run as part of the normal certification for your platforms. It's important to note that we had some late-breaking changes in the logo requirements shortly before Beta 2. The version of Aero AT in the Beta 2 WDK is old and does not reflect the version of the logo requirements that would be available to you as soon as they're published. And I'm sorry, I don't have the exact day that the 1.0 document will be published. It's during WinHEC. So if you don't have that available to you now, it will be available to you very, very shortly, the finalized document, that is. I am posting a downloadable zip file on the WinHEC site on Thursday of this week that you can download that will have the latest version of Aero AT in it that you can use for testing and evaluation on your system. That will also include some other documentation too. As you can imagine, given the technical detail, the technical nature of the requirements for Aero, it's very difficult to talk about this with a technical audience such as yourselves, let alone consumers. It would be very hard to tell my mom, the canonical mom, oh, Mom, well, you want a PC that's got 1,600 megabytes of bandwidth and does 32 bits a pixel and has got a WDM driver. Clearly, that's not a message that can be taken to consumers by anybody. The good news is that we've actually thought about this, and we have a set of tools that are available to consumers to help them make these type of determinations about PC. The first one is the Vista Upgrade Advisor. The early beta that was posted late last week on the Get Ready site for download, and hopefully, who here has not run the Vista Upgrade Advisor? Oh, great, a very small number of people. Download it and file bugs. It's going to be a very, very important tool for us to get right because it will be the tool that we ask consumers to download and run on their PCs that will let them know how capable their PC is running Vista. We'll let them know what features and which SKUs will run well and whether or not they'll get Aero and answer their questions around those type of things. The other interesting thing is that Windows Vista itself helps the consumer out. It will automatically turn on Aero if the system is capable enough to run that feature. It does that by running the Windows System Assessment Tool. WinSAT runs during machine UBI. Who here is not familiar with what UBI is? Should I dive into that a little bit? A few people? So UBI is called the out-of-box experience, and you'll see this when you install Vista. The first panel of UBI or we call it the language panel, and it asks the user what language they want to run in and what dialect, and once we know that, then we can follow through the interface. It asks what time zone they're in. It helps them pick a username and a name for the PC. When appropriate, it will ask them for their product key and help them set the desktop background. WinSAT actually runs as a part of that process, measures the performance of the graphics subsystem, and provides that information to the desktop composition engine. The interesting thing here is that this is designed to be helpful to the user. In other words, the user can always override the automatic decisions that Vista makes. In other words, if they have a marginal graphics subsystem and Vista says, I really don't want to go turn this feature on, or I may turn on desktop composition only and not turn on what some people refer to as glass, the transparent window borders, the user can always go override those settings, turn on what he or she likes, or even turn it off if he or she desires. You will see there is one bug in the operating system with respect to this. There's a corner case where if the operating system has decided to turn on desktop composition, but not turn on glass or the transparent window borders, the user interface has a bug in it where they can check the checkbox and Vista erroneously clears that checkbox. You guys may run into this. It doesn't happen all the time, but it does happen relatively frequently. And unfortunately, that was not a bug that was able to be fixed in beta 2, but that will clearly have to be something that's fixed for beta 1. For RC1. So WinSAT is the tool that makes these type of performance measurements, and it's the primary tool that provides the performance information for the desktop composition engine, but also does a few other things. It measures the performance of the system processor, system memory, the graphics subsystem for Aero and for gaming. It measures the system's ability to play back certain types of video clips, and it also measures some of the performance for disk. I don't know how many of you were here for Gabe and Matt's presentation on the Ready Boost features and the related technologies. But that tool can also be used for measuring the performance of USB sticks and their applicability to those features. So, as we discussed, WinSAT's used to help enable Aero. It's also used as the fundamental performance measurement tool for Aero AT. Aero AT is essentially a wrapper for WinSAT, runs it several times, and also checks the memory sizes. WinSAT's used in the Vista Upgrade Advisor. And it's also used as part of the data from it's also used during the Windows Anytime Upgrade feature in Vista. Who here is not familiar with the Anytime Upgrade feature? Good. I don't have to go into that too much. The metrics from WinSAT are also used by some of the other features in Vista to make scaling decisions. In other words, do more or present more features or be more aggressive about certain things on more capable platforms and more conservative on less capable platforms. WinSAT's also going to be, or at least we hope it will be, a very good tool for enthusiasts and other performance people in the industry to help measure the fundamental performance of subsystems on a PC. It's also very good, as we've discovered recently, as a performance diagnostic. WinSAT runs every time Vista is installed. So every copy of Vista on every PC is guaranteed to have WinSAT data on it. Notice, so the data necessary to make the scaling decisions that Vista needs to make with respect to features in Aero. And the reason is because it runs during the machine UBI process. WinSAT can also be run to reassess the system's capabilities from the performance control panel, or programmatically using the COM API that we've included in the operating system. So not only can users use this, but software applications or other installers can also use WinSAT to make their own performance evaluations differently than the way we use it for the operating system. It's important to note that WinSAT itself does not run automatically to reassess the capabilities of the graphics subsystem after the driver has been updated or if the graphics subsystem is changed. In other words, someone may purchase or have a PC that's got lower performing graphics and want to update to a higher performing graphics card to either get desktop composition Aero or to get a higher performing graphics subsystem. WinSAT or Vista does not automatically detect this and rerun the tool. That was our original plan of record and what we really wanted to do, but we ran into some relatively insurmountable problems with respect to this. One of the most interesting ones is that it would require some prompting of the user. How many of you have seen the elevation prompts, or what we call UAC in Vista, where you're asked for permission before you do an administrative task? Everybody's seen that, right? So we would have to prompt the user. They would have to go through those prompts. One of the things that we learned from talking with people that were very experienced with these type of user interactions is that unless it's something clearly initiated by the user that they really want to do, they almost always say no. They're just kind of conditioned to that. So even if we had this, it wouldn't be very beneficial because most users would say no. And that's even in the case of, we had all kinds of texts and say, hey, you really, really, really want to do this. This is very beneficial to you, and we'll go do some cool things automatically for you if you say yes. Even with that kind of language and as careful and proactive as we want to be about it, users almost always say no. The UAC elevation thing is something that we wanted to avoid. But the biggest problem that we ran into is that, especially in the case of when a consumer may be upgrading from a PC and have XP drivers and are upgrading the WDM drivers either just the driver, or when they plug in a new card, is that there is no clear time when to rerun the tool, because oftentimes this requires a reboot, or there may be other software installed along with the driver. For example, someone buys a new graphics card at retail that always comes with more software than just the driver. It comes with players and screen rotators and all kinds of other interesting things that the IHVs provide to add value to that card. Often those software installation processes are relatively long and involved. It would be really harsh to pop up some WinSAT UI asking the user to go do this right in the middle of the software install from one of the IHVs. Would not be a very good user experience. So what we've done is we've working with our major IHV partners, and the actual solution to this is actually very simple and actually very good for the user. We just ask them, hey, rerun WinSAT when you install the software or the driver for your card. Right? So the user has already desired to do this. They've installed the new card. They're installing the software that comes from the IHV. Right? There's a lot of software being installed. Elevation has already happened, so we don't have to prompt the user with a UAC prompt. There's already a software installer interacting with the user, explaining what's going on. It's a very natural time just to rerun the tool, so things happen automatically just as it would in the normal flow of things. WinSAT itself is a pretty straightforward tool. It's both 32-bit and 64-bit. It actually runs on XP. We don't have a separate downloadable or anything for WinSAT for running on XP. If you have Vista, you have WinSAT. All you need to do is copy the executable onto XP and it will run just fine. We actually build WinSAT slightly differently in that regard than other Vista components. Most Vista components won't run on XP. We actually had to design and build WinSAT in a way to facilitate that. WinSAT is multi-core and multi-CPU aware where appropriate. Specifically, that's in the memory assessments and the CPU assessments. The canonical output of WinSAT is XML. The other important thing is that with respect to multi-core and video, there is no specific multi-core awareness with respect to the video codecs in WinSAT. We simply use the built-in components in Vista for that. The same codecs that Windows Media Player uses and the same Media Foundation or Direct Show components. And many of those components are multi-core aware and are being further optimized to provide better performance on multi-core systems. It's important to note that WinSAT itself does require elevation. We use certain kernel resources like the kernel logger and other APIs and things in Vista that require administrative privileges. So if you run WinSAT, you need to run it from an elevated command prompt or you'll see that elevation. If a user goes and reruns the assessment from the performance control panel, they'll be prompted with an elevation prompt. WinSAT itself is very simple from a structural perspective. It's a single executable. There's no extra DLLs or anything that goes along with it. That's not built into the operating system. That's why it's very simple to copy to XP and run. We don't need an install or anything for that. There's some data that it takes that we store in the WinSAT directory under Windows. It writes its XML data out to a specified directory, and it interacts with the COM API in a very straightforward way. It's not a complex tool at all. The API itself is all COM-based. It's fully scriptable from Visual Basic, JavaScript, PowerShell, HTML. It provides a very simple programmatic way to do everything with WinSAT that you would need to do if you were an IHV or an ISV and wanted to leverage the capabilities. And the API allows you to read the data that WinSAT is saved in the XML files or actually run WinSAT again or run it in a way specific to your tool. You're not limited to just what we call the formal Vista assessment that WinSAT does. You can actually run it however you would like. Last year when I gave this talk, we talked about a C-style API, and that's actually been documented and MSDN is up on the web right now. We have deprecated that. The reasons we ended up with a C API in the first place, the things that drove us to that have gone away, and we don't need to do that anymore. And what we've settled on is a very simple, very straightforward, scriptable COM interface. It's actually easier to use than the old C-style API was. And again, the API itself does not require elevation. So an application can actually use the API to read the WinSAT data from the XML files, or actually just find and read the XML files directly without any elevation. It's all readable from a standard user mode application. The data store is pretty straightforward. It's just a series of XML files stored in a directory. The API and WinSAT itself will keep up to 100 of those, and once it gets past 100, it'll just delete the oldest XML file. There is one exception to that. And you'll see this when you look at the XML files down in the data store directory. We call one the initial assessment, and we never throw that away. That's always the very first assessment that happens on a machine. We always keep that one around. Typically, that's the one that generated during the UBI process. The graphics assessment from the command line is called DWM, and that is the one that most people are very interested in. It's the one that generates the megabytes a second score for Aero AT and is used to assess a system's ability to run Aero. The primary metric is, no surprise, megabytes a second of graphics memory throughput. The interesting thing about this test is that we structured it in such a way as the metric reported by the test correlates extremely well with the behavior of the DWM. We actually have a model that's quite predictive of things like drag move times or the time it takes to go in and out of Flip 3D mode or pop-up thumbnails can be quite accurately predicted simply by using the throughput value computed by WinSAT. The D3D assessment is focused on gaming. It's very similar to the DWM assessment, but drives the hardware much more in a way that games would drive a hardware. It's more focused on shader and vertex performance and less on fill rate performance like the DWM assessment. And again, the assessment is a very straightforward assessment, and it's meant to help us just rank or get a first order judgment of the performance of the graphics subsystem as it relates to gaming in the system. The system memory assessment is also very straightforward. It's focused on throughput and not latency. In other words, WinSAT doesn't measure things like L1 or L2 cache latency like more comprehensive or more sophisticated tests that many benchmarkers use. It's focused strictly on large buffer copy movements. One of the reasons for that is that's one of the key performance determining factors for many things that happen inside an operating system, is the ability to move large buffers around. That's why we measure it the way we do. The storage assessment, or the disk assessment, is a very interesting assessment. It supports sequential reads and writes and random reads and writes. It's a sweep. It's what some people call a sweep test. We segment the drive into a set of areas and do a performance assessment on each one of the areas. That allows us to develop a performance curve for the drive. In other words, we can detect where the fast parts of the drive are and where the slow parts of the drive are. Like many of the other assessments, the metric is megabytes a second. And we roll up a single metric for the drive, and we also report the metrics for each of the subsegments of the drive that we measured. The formal disk assessment, that's part of the assessment that we run on every Vista machine, only includes sequential read performance. It turns out that we don't need to run all 4 assessments to get a pretty good first-order judgment of how performant a drive is. Sequential read performance is a really good indicator of the overall performance of the drive. However, we did keep and retain the other 3 assessments in the disk, in WinSAT, so other people can use that as a more sophisticated tool for measuring drive performance. The processor assessment is really designed to give a good first-order ranking of processor performance. It's fully multi-core aware, and most importantly, it is not a synthetic test. In other words, when we want to measure video encoding performance of the processor, we didn't just go implement IDCTs or some other piece of the codec in a synthetic way, run that in a tight loop, and then make some leap of faith on, yeah, that's pretty indicative of video encoding performance. WinSAT actually runs the full video encoding pipeline. That would be the same pipeline used by Media Encoder or any other application that wants to encode video in Windows Media Video, or use the same pipeline to encode MPEG-2 or any other format. The other assessments that we implement for CPU performance measurement are compression and encryption. And there again, they're not synthetic tests. They use the same components in Vista that many other features use. Specifically, the Ready technologies, Ready Boost and Ready Drive, we use the same AES encryption engine and the same compression engine that uses. And the reason is we wanted to measure the CPU in a way that was relevant to how applications really use the operating system. Here, though, unlike an application, WinSAT is fully multi-core aware. We spin up one thread per logical CPU in the system and run those in a relatively sophisticated way to get a really good judgment on how well the processors scale or these workloads scale on multiple cores. Oh, and of course, we have full parity between 64-bit and 32-bit. Oh, on an interesting note, the 32-bit version of WinSAT actually detects that it's running on a 64-bit system and errors out with a message that says, please run the 64-bit version of WinSAT on a 64-bit system. So one of the things we didn't want this to be used toward, or because it would lead to a lot of problems and questions, is trying to run 32-bit, these 32-bit workloads on a 64-bit system. So if you do any testing and performance analysis, you'll run into that. And that's actually by design. The video decode assessment is a very interesting part of WinSAT. And it's designed to help judge how well a system can play back a particular video clip. And again, this is not a synthetic test. WinSAT can play any video clip and run it completely through the appropriate pipeline, either the DShow pipeline or the Media Foundation pipeline. WinSAT can measure the performance of MPEG-2 playback, Windows Media Video playback, H.264 playback. And the other nice thing that you'll see in RC1, and I'll talk about this again in a little bit more detail, is per frame decode times and some other interesting metrics about video playback. So one of the things that we actually use WinSAT for in our perf lab are perf diagnostics. It turns out that the memory assessment in particular is very, very good at finding configuration problems with PCs. For example, we have large numbers of identical PCs in our lab. And very often we'll see something, well, why is this PC performing slowly? What's the problem with it? And we learned very early on, well, the first thing you want to do if you see per PC performance differences is go run the WinSAT assessments on them. And many, many times when we get new PCs in or have some custom white box PCs built, we'll discover that 1 out of 10 or 20 will have misconfigured RAM. In other words, the BIOS will not have configured the RAM correctly, or a stick will not be seated correctly, so the system will be running with half the amount of memory, or it'll be running with the memory in single channel mode instead of dual channel mode. This assessment is very, very good at picking those kind of things out and finding those kind of problems. So we encourage people to use this as a baselining tool for system performance. You will see some differences when you run WinSAT on Vista versus XP. These are primarily due to the fact that WinSAT is very dependent upon large software stacks in the operating systems, for example, the codecs or the encryption providers or XP versus WDM drivers. So it's not the test itself that's different, it's the deltas in the components being used by the assessment. We wouldn't have seen this if we had stuck to a purely synthetic test where everything was built into WinSAT, right? But we wanted this to be much more relevant to applications than you could get with just a pure synthetic test. So you will see differences between Vista and XP. And that's true even for the processor assessments, because we do use the built-in encryption and compression components in the operating system. So we're going to do a little bit more work post-beta 2 for RC1 and for RTM. We're not quite done yet. Like I talked about, we're going to include per frame decode times in the video decoding assessment. And we're also going to include CPU utilization for video playback assessments. And this is really interesting because it allows a good analysis of efficiency of video playback with respect to where the video is played, where the video playback is accelerated. Lastly, one of the things that the metrics for WinSAT are used for is the Windows System Performance Rating System. And I'm only going to talk about this briefly because this is the Hardware Engineering Conference. WinSPR is designed to help solve some consumer problems. It helps consumers understand how well their system will support certain Vista features, and it allows consumers to better match software to hardware capability. The user interface is very straightforward. Many of you have probably seen this in earlier builds of Vista. One of the key things that people do need to understand about this is that the top level score is not an average or arithmetic or geometric mean of the system, of the subscores. It's simply the lowest common integer of the subscores. Very, very straightforward. From a future technologies perspective, WinSAT is an ongoing development project. It's not just part of Vista RTM. It's something that we want to maintain and leverage and use in more sophisticated ways as we move forward. One of the things that we're working very closely with our key IHV partners on is how do we support DX10 in future versions of WinSAT? How do we do a good assessment of how well the system can support DX10 operations? And that's not just for gaming. That can be for any other thing that uses DX10, such as leverages the advanced scheduling in many of the new graphics cards. So, what can you guys do? How can you guys help us? The first thing to do is understand the logo requirements and how they apply to your systems. Use the Aero AT test to understand the performance of your hardware and how it relates to logo, and does it meet the requirements, the performance requirements for the premium logo. If you're close, or you feel that your graphics subsystem should meet the logo requirements but are not, let us know, and we can help you through that. We still see some driver issues that cause the performance scores to be relatively low in some cases. Make sure that WinSAT works with your graphics drivers and the other components in your systems. We still see from time to time where there are driver bugs that prevent WinSAT from running correctly. Very rare instances, we still see some blue screens, but more often, there'll be a problem in the driver that causes WinSAT to generate what we call a zero score. In other words, it'll run, it'll look like it works, and the score coming out of WinSAT will be 0. Traditionally, we've not found a problem in WinSAT that causes that. It's always been a driver issue. So please check that when you're evaluating graphics drivers. And lastly, give WinSAT a try as a performance diagnostic. We found it to be quite effective. There's some other additional resources I mentioned earlier. There'll be a downloadable version of WinSAT in a couple days up on the website. That'll include the Aero AT tool that accurately reflects the current logo requirements. Be a tool for translating XML files into CSV files, which is quite useful, and a bunch of documentation. Here is also a link to the latest logo requirements and to the Get Ready site.